Hello, everyone. Welcome back. So today we want to talk about solving quadratic equations, talk about kind of two special cases, and then mention the quadratic formula, which to solve any quadratic equation. So our goals are the two cases we're looking at to be able to solve the quadratic equations by factoring where possible. We'll give you one scenario, one situation where that's the best thing, definitely the best thing to do, and will always work. And then be able to solve quadratic equations using what's called the square root property where possible. There's also a situation where that's also your best move. So remember, a quadratic equation is a polynomial equation. Basic looks like this. Your highest power is the variable, whatever your variable is. In this case, it's x. This is your second power. And in general, we can have something that can look like this. All right. So ax squared plus bx plus c equals 0. It can be written that way, where the a is not 0. A, b, and c are constants. A is not 0 because if this term is a is 0, this term is missing and it's not quadratic anymore. But the b and the c can be 0. So what that means is you can have all three terms, so a squared term, a single variable term, and a constant. Or it's possible you can also have this middle term missing or the constant missing. That's still a quadratic equation. You have all three, or you're missing either one of those, but you always have to have the first one, because that's where the squared comes from. Now, in our solutions, it says it can be real numbers, imaginary numbers, or complex numbers. Now, we can solve these equations by factoring. So if the c is missing, and this will always work by factoring, if the c is missing, meaning this constant term here is missing, but the other two are there, then it looks something like this. Okay, just no constant. And this we can always solve by factoring. So you can always factor an x out and solve it that way. And here I kind of go through the process. If not, we can't write it that way. I have set one. So basically, we can solve the quadratic equation by factoring this way, if we can write it this way. So if it's not already in this form, we write the equation in the form above, okay, like this. Factor it completely, and then set each non-constant factor to 0. The results are the solutions. Now, in general, as it says, quadratic equations won't factor. You have to use another method, and the best method for that is the quadratic formula, which I've done another video on the quadratic formula, so you can see that. But often in application problems, functions like this often do factor, so that's something we want to look for. Okay, so let's look at an example of this first one. So over here, I would simply say to solve. So number one, let's say you have something like this. X squared minus 3x is equal to 0. Okay, now this is a quadratic equation. Our highest power is x squared. You notice comparing it to this, we have the squared term. We have the middle term, we don't have a constant term. In this case, we can factor an x out. That's the reason why this method is useful. So we can factor out basically the greatest common factor. Factor out x. If we do that, we have an x times, and what's left is x minus 3 is 0. Okay. Now, in this form, we can solve this by factoring, because if it's now it's in factored form, if either x is 0 or if x minus 3 is 0, then this side is equal to 0 and makes it a true statement, 0 equals 0. So the goal is to find out what's going to make x 0 and what will make x minus 3 0. Those would be solutions to the equation. So to set one equal to 0 and solve. So over here, this is already solved. Over here, just add 3 to both sides. So x is equal to 3. So our two solutions are x equals 0 and x equals 3. Okay, if you plug in 0 for x in both cases, this first factor be 0, make this side 0. If you plug in 3 to both x's here and x here and here, will make this factor 0, which will also make the left side 0. So those are solutions. Now, number 2, let's do another one. This time, let's say we have 2x squared is equal to negative 8x. Okay. Now, in this case, generally with any kind of quadratic equation, in most cases, you want to set it equal to 0. So I'll just make the right side 0. So I'll say get the right side. Oops. Looks like, make sure this looks like a G. The right side equal to 0. So I'm going to add 8x to both sides. This will give me 2x squared plus 8x is equal to 0. Now, once again here, I want to factor out my greatest common factor. In this case, that's a 2x from both. And so we have 2x, and if I take out a 2x, from this term I just have x left. From this term I have 4 left. Okay, you can always check that to multiply it back through. Now here, so we can do a good practice. If you have a constant factor up front, just divide both sides by that. So I'm going to say divide by 2. So we'll divide both sides by 2. That will just get rid of the 2. Because the 2, since it's a constant, can't be 0. So it doesn't really matter. So what we have left then is x times x plus 4 on this side. And over here, 0 divided by 2 is 0. At this point, do the same thing I did above. So I set each factor equal to 0. Non-constant factor, so x is equal to 0. X plus 4 is equal to 0. So x is equal to 0, that's one solution. Then if I subtract 4 from both sides, I get x is equal to negative 4. And there's my other solution. One thing also I failed to mention, but generally the quadratic equations, you don't expect to have 2 solutions since we have a squared term. And most of the time you will have 2 solutions. Occasionally you have 1, but most of the time you'll have 2. Okay? Now, so that's what happened. Now let's look at one more case where you can factor. Let's look at this. So y squared minus 2y minus 15 is equal to 0. Now this is not like the other case. All right, so this is, I'm just showing you this separately. So in this case, we have all 3 terms. We have, compared to this one, we have all 3 terms, the squared term, the single variable term, and the constant. Now what I showed you before, you can always, if you're missing the constant, if you have the squared term, the single variable term, you can always factor it, okay? Now this is an example of one where actually we can factor. So if you know how to factor it, it's something you can do. If not, you can always use the quadratic formula, okay? But this will factor, if you notice then, this will factor into y minus 5 and y plus 3. Once it's factored, do the same thing. Whatever makes either one of our factors 0 is a solution because it's make the left side 0. We set each non-constant factor equal to 0. Y minus 5 equals 0. Y plus 3 equals 0. And so for our solutions, we get y equals 5 and y equals negative 3. Now, once again, if you didn't see that or don't know how to factor it or have trouble factoring, you can also use the quadratic formula. Okay, the factor. It's also a choice. Okay, now that's our first case, kind of an unusual case. Now let's take a look at our second case. And that's a case where actually the only term you have is the square term, okay? Or except, I'm sorry, not. What's missing this time is a middle term, okay? Not the only case, not the only term. You're missing this middle term, missing the single variable term. Let's take a look at that. Okay, this is what's called solving using it's called the square root property. Okay, so over here, once again, we have a general form. Now, what we're missing, if a b is 0, which means we're missing this middle term, have a quadratic equation that looks like this. Okay, just a square term and a constant. Well, in that case, you can't really factor it. And you can also use the quadratic formula, but the best thing to do is what's called the square root property. Okay, and essentially we're kind of taking the square root of both sides. So the property, what it says, if you have x squared equals some number k, that means that x equals plus or minus the square root of k. Okay, so you have our 2 solutions right here. Either x is equal to plus k or positive or the negative version of the square root of k. So to solve one like this, what we'll do, and as we'll see with all this procedure, we get the square term by itself if we have to. Use the square property, which is like taking the square root of both sides. And then if we need to, also solve to get the variable by itself if we have to do that as well. So let's look at a few examples of this. Once again, our directions just be to solve. Number 1, let's do a basic one. So just x squared is equal to 20. One's already set up in the right form. Okay. Now here, this is a quadratic formula since our highest power is x squared. Our highest power is set the second power. You notice we don't have an x term. We don't have just a single x term. We also have a constant. This is already set up in the right form. Okay. So here we're going to use the square root property. What that means then, So I like taking the square root of both sides. So if this is true, then x squared is this, and x equals plus or minus the square root of 20. So two solutions. Okay. Now, you also have to make sure with the square root, make sure you have both. I also want to simplify our radical. So if you recall doing that before, plus or minus, then 20 is not a perfect square, but there's a perfect square inside of 20, so which is 4. So I can write 20 as 4 times 5. Then I can break this up, since I'm multiplying, I can break this up into two radicals. So I have plus or minus the square root of 4 times the square root of 5. Of course, the square root of 4 is 2. So my final answer is x is equal to plus or minus 2 times the square root of 5. And those are my two solutions. Okay. So once again, this is what's called the square root property. And so this is when we're basically missing the middle term. We have no single variable term, just a square term and a constant. We can always do this. You can also use the quadratic formula anytime you want any quadratic equation. It's better, one like this is better to use this way. Okay, let me check and make sure I have enough space. Yeah, that should be enough. Now let's go back here and look at number 2. Okay, let's say we have this one. Negative 3y squared minus 6 is equal to 0. Okay, now this kind of looks more like this right here. Okay, once again with the same thing, there's no middle term, there's no single y term. So what we're going to do first here is want to get the y squared by itself. I'm going to make it look like this, or make it look like the one we just did. Put it in this form where we have x squared equals some constant. Okay, so let's add 6 to both sides so that we have negative 3y squared is equal to positive 6. Divide both sides by negative 3. And then we have y squared is equal to negative 2. Okay, now you notice this is negative, and that's okay. And once again, I want to use, let's abbreviate that, the square root property. Abbreviate that. And so, since you take the square root of both sides, and so this is y, if y squared is equal to this, then y is equal to plus or minus the square root of negative 2. Okay, now, remember, this has a negative under square root. This is going to involve I. What I'm going to do first is put in what I call I form. Okay, so write it as first as y is equal to plus or minus I times the square root of 2, or the square root of 2 times I, either way. Now, also, you want to simplify if possible. In this case, we can't. It's square root of 2, we can't simplify that. And also, I'll simply say, or we can write it as y equals plus or minus square root of 2 times I. Let's make sure the I is not under the radical sign. Okay, so look at one more, number 3. And let's say in this case, let's say we have x plus 3 squared is equal to 27. Okay, now this one looks a bit different. As we'll see, it still works the same way. You still have a squared term, but there's no single variable term by itself. So this is kind of a special case. We can solve this way. Once again, what we want to do then is use the square root property. So essentially take the square root of both sides. So if this squared is equal to 27, then x plus 3 is equal to plus or minus the square root of 27. Okay, now also here we can simplify this. We can simplify this radical. 27 is not a perfect square, but there's a perfect square in 27, which is 9. So we have x plus 3 is equal to plus or minus 27, which is 9 times 3. Then we can separate this, break this up in the square root of 9 times the square root of 3. We won't do that since we're multiplying. For adding, we couldn't do that. And of course, the square root of 9 is 3. So we have x plus 3 is equal to plus or minus 3 times the square root of 3. Okay, now we're not quite done. So we want to get x by itself. Yeah, so this last step, it says solve to get the variable by itself if necessary. That's what we have to do here. So we want to get x by itself. And if we do that then, so subtract 3 from both sides, we have x is equal to -3 plus or minus 3 times the square root of 3. And once again, we still have two solutions. One is, let's write both these out. We have x equals -3 plus 3 times the square root of 3. And our other solution is x equals -3 minus 3 times the square root of 3. So we still have two solutions here. Okay, so what we've learned so far is we have a couple special cases in which we can solve the quadratic formula, which is a lot faster than using the quadratic formula. Okay, so the first case we looked at is if you're missing the middle term, it looks like this, where you have a square term and a single variable term. You can always factor this, as we did this first couple examples, and solve that way. Now, the second case is if you're missing the middle term, where it looks like this. We have the square term and a constant, the way we did the last few examples. And then you use the square property to find your solution that way. Now, and I also did one example where a trinomial where you can factor that, although you don't always know you can. So the advantages of that, if you know you can factor it, especially something like this, is quite easy to factor. That's the best way to go. But if you don't know if you can factor it, and there's not always guaranteed you can factor these. And if you're not sure if you can factor, a lot of times it may be better to go ahead and do the quadratic formula than trying to spend time trying to factor. But any of these we've done can always be solved with the quadratic formula. These are special cases where this is your best and quickest way to solve the quadratic equation. Thank you. Have a good day.